Okay, guys, shall we start? Um, just let me know in the chat box if I'm not clear. You can send me a direct message on the chat box if I'm not clear. Or as a group for the world. I hope you know how to select that in the chat box. Just select Sanjay and send it across to me. If I'm not clear. So what I'm going to do today is we'll try to go through about 7 questions. Um, Covering most of the areas that we've covered and questions that are quite relatable to the exam questions also. So first, let's start off with the question number one. What I want you to do is take 10 minutes. Now it's 1:10. Take 10 minutes and try and do this question. And once you're done, just send me a message saying done on the chat box, either privately or to the whole group. So take 10 minutes to do this question and then I'll go through it. Okay, I've uploaded the file, guys. You go to your Moodle, go to week 3 to 7. I've uploaded the file called, it's named as revision, as you can see here. So just download it and keep. Let me try and work out this sum, switching on my camera. But if in any case it's not going to work, I already have the answers also. But let me try and switch this on. But download this file and keep, so that it's easy for you all. Now, if we look at this question, the first thing that you have to understand is when they talk about on average, website receives 10 visitors per minute. And the question asks, calculate the probability that in a given minute, exactly 8 visitors comes to a website. You need to understand this is a discrete random variable, and they're talking about discrete distributions. And under discrete distributions, they're talking about Poisson distributions, because they're talking about an average of 10 visitors per minute. So when they talk about something like this would be a Poisson distribution. So that's the first thing you identify. So how do you go about doing this? And by the way, if I'm not clear, please send a message. I hope you all can see this. So what you'll have to do is, so you have to identify that lambda is equal to 10. And this is 10 visitors per minute. You note that down. And I'm going to define something called K, which is the desired number of occurrences, which is equal to 8. And then the first question would ask me, what is the probability that lambda equals 8? So, sorry, K equals 8. So what I'm asked is probability of K lambda. I know the equation. So in the exam, you'll be provided the equation. So I'm assuming you have it with you with the notes that are given. E to the minus lambda, lambda to the power K divided by K factorial. So e to the power minus lambda, lambda is 10. 10 to the power K, in this case, is 8 divided by 8 factorial, which will equal to, so if I take out my calculator and do the sum. So in this particular calculator, I have e to the power minus lambda is minus 10 times 10 to the power 8 divided by 8 factorial. Factorial is over here, right? So that will give me 0.1126. 0.1126. So what is 0.1126? I would say the likelihood of exactly 8 visitors, coming to a website in any given minute, minute is approximately 11.26%. So that's the first part. If you have to answer the second part, so over here, what they're asking is, what is the probability that there are more than 10 visitors? So as I've told you before, to answer a question like this, you need to look at 11 visitors, 12, 13, 14, 15, likewise, which you can't do. But you know something else, which is the total probability. You know that the total probability is 1. And from 1, you can deduct probability that K is less than or equal to 10. That means the number of visitors is 10, 9, 8, up to 0. So if we deduct 1 minus this, so how do you write this figure down? This is simply e to the minus lambda, lambda to the K factorial is a Poisson distribution. But you're going to sum it up from K equals 0. K is the number of visitors, or visiting the website, k equals 0 to 10, right? And here, what I can do is I can take e to the power minus lambda out of this because e and lambda are not part of k. So k is the variable here. K is the variable. So I can take e to the power minus lambda out. Sigma k equals 0 to 10. Lambda to the power k divided by k factorial. Now I simply substitute in the values. E to the power minus 10, lambda is 10. Sigma k equals 0 to 10. Lambda lambda is 10. 10 to the power k divided by k factorial. Now how do I do this? In the calculator, it's 1 minus e to the power minus 10 times sigma is over here. So I click shift and sigma. I get that value. So that is 10 to the power. So my variable here in the calculator is simple x, although I have used simple k. So I'm going to use x here. Alpha to the power of x divided by alpha x factorial. Factorial x is going from 0 to 10. In the calculator is x. In my written sum, it's k. Same thing. So I would get 0.4169. 0.4169. So what is 0.4169? Let's leave this calculator like this. I hope you can see. Drop me a message if you can't. What is 0.4169? That is the probability that more than 10 visitors visits a website in a given minute is approximately this figure, 41.69%. That's the answer. So if you have any questions, please let me know. If you have any questions, drop me a message on if you're not clear, or just unmute yourself and ask the question. So in the PowerPoint presentation that I shared on Moodle, the answer is there. But what I'm going to do is I'm trying to go and do it here as well, so that you can see what I do on the calculator as well. So if you have any questions, please ask now, or if not, we can move on. So there's a question, is it okay to give the answer as a percentage, or we'll stick to a probability value between 0 and 1? Yeah, it's fine. You can give the answer as a probability value between 0 and 1, but make sure that you interpret it. That's very important. But also you can do what I have done here as well, which is I figured out what the probability value is, which is obviously between 0 and 1. And when I'm interpreting it, I use it as a percentage value and I tell what the probability is, or the probability value is. Or you can give this as a percentage value or as a decimal point, completely fine. Okay, shall we then move on? Let me switch off this camera and go to the second question. Okay. This is the second question. So take again 10 minutes, try it out, send me a direct message or a message saying you're done. So take 10 minutes and do it. Okay, let's have a look at how to answer this question. Stop sharing. Okay, so first thing is you need to understand when you're reading this question, uh, what is this asking? So they're asking calculate the probability that the sample mean satisfaction score is between 7.4 and 7.6. So first thing you have to identify is this is a question from the sampling distribution section for sample means. So you have identified that question. You have identified that. So afterwards, what you do is it's to first thing is that you have to identify that the sample size is greater than 30. So because of that, you say since n, my sample size, is greater than 30, according to, I'm going to use the famous theorem that we spoke about, according to the central limit theorem, according to the central limit theorem, what can I say? The sampling distribution, the sampling distribution, it is distribution in short form, distribution of sample mean will be approximately normally distributed. That's an important statement for me to make at the outset of answering this question. Thereafter, what am I asked? Very simple. Then, what is the probability P that my X bar sample mean is in between 7.4 and 7.6? Write this down because then you understand, okay, this is what I'm asked. Right. So you can't do much using these numbers. You standardize this. So how do you standardize this? You standardize it into Z. How do you standardize it into Z? It's X bar minus mu over sigma over root n. So you do the same thing for these two numbers as well. X bar is 7.4 in this case. Mu is given, which is 7.5. Mu is 7.5 divided by sigma is given as 1.2 and sample size is 50, square root of 50. On this side, it's 7.6 minus mu is 7.5 divided by 1.2 over square root of 50. So then I calculate these two values. Calculator. So it's 7.4 minus 7.5 divided by 1.2 over the square root of 50. So I get minus 0.589 on this side. In the middle, I have Z. And on this side, I would get same, everything is same except for this part, 6 plus 0.589. So rather than keeping it like this, I can round it off to minus 0.6 and plus 0.6. So what are they asking for? What did I have before? Initially, I had X bar values, right? So they were asking for 7.4, 7.6, and in the middle you had 7.5, which is mu. What I did was I standardized this to Z, so that in the middle I have 0, this side I have minus 0.6, and on the right hand side I have plus 0.6. So what I'm asked for is what is the probability in between these two areas, right? So in order to do this, what I'm going to do is very simple. I'm going to calculate the total probability coming from this side up to 0.6. From the leftmost corner up to plus 0.6, I'm going to calculate the probability. And from that probability, I'm going to deduct this probability over here, this little part. And if I do that, the remaining part is the probability that I require. Okay. So what did I say? Let me quickly repeat. From the left-hand side up to 0.6, I'm going to calculate the probability minus from the left hand side up to minus 0.6 area. I'm going to deduct this area so that I'm left with this. Right. For this, you will need to look at the Z table. So let me share the screen and show you the Z table. So what I need is from 0.6, where is that? 0.6 is 0.72575. 72575. I'll show you my working table, but from this value, I need to deduct the value that I get from negative points. 0.27425. Okay. Now let me stop sharing and switch on the camera. Okay. So this is what I have done. So 0.75275 is the value, that is the probability from negative from the leftmost side to plus 0.6. So this whole area, that is 0.72575. From this whole area, I'm going to deduct this part, which is 0.27425. So that would give me 0.7575 minus 0.275. 0.45, 54515. Right. So if you did not round it up to 0.6 like I did here, and if you consider 0.58, negative 0.58 or negative 0.59, your answers may slightly change. That's completely fine. Your answer should hover around the mark of between 43 and 45, 0.43 and 0.45. Right. So what does this tell me? This tells me that the probability that the sample mean satisfaction score is between 7.4 and 7.6 is approximately 45.15%. Your answer may have changed because you may not have rounded it off over here. But as I said before, your answer should be somewhere around 0.43 and 0.45, somewhere in between those two numbers. Now, in this case, if you have any question, please either unmute yourself and ask the question, send me a direct message, or send a message to the whole group so that everyone gets. If you have any question, please ask. If you have no questions, we can move on to the question number 3. If you have no questions here, everything is okay. We can move on to question number 3. Seems like everyone is okay for now. So let me stop the video. Share the screen. Let's go to question number 3. Take 10 minutes again and try this question. Let's take a look at this question as well, guys. I think this shouldn't take that long if you're familiar with the concept. First things first, we need to identify what is being asked here. Out of all this information, first we need to identify what is important. They are talking about a sample of 30. So the sample size is given as 30. And then sample mean is given here as well, sample mean, which is 120 days. And the sample standard deviation is given for 20 days. What are they asking? Form 95% confidence interval, right? So that is from the confidence interval section for the true mean project delivery time for mu, right? So sometimes in the exam, I might not even give this section, give this area, because it's not needed. Why is that? Because you're only given the sample standard deviation. So then you should identify that, look, I'm not given the population standard deviation. I'm only given the sample standard deviation. So therefore, I need to use the t-distribution for this. So there is a confidence interval estimation for population mean when population standard deviation is unknown. That's the section that this question is testing. Okay, let me stop the share and switch on this camera. And let's see how we are going to attempt this question. Okay, so what I'm going to write is since the population standard deviation, is not provided, we will use the students t-distribution. I'm going to make that statement so that the examiner knows, okay, this person knows what he or she is doing. Next up, what am I asked for? I'm asked for confidence interval estimation for mu, that is the population parameter for mean, equals the sample mean plus or minus. I'm going to use the t-distribution. In this case, alpha divided by 2. Remember, there's something called degrees of freedom under t-distribution. In this case, it's n-1, sample size -1, times S, sample standard deviation, divided by n. Now I simply substitute the values. X bar was 120 plus or minus. Let me find this value from the table. Let's keep it for now. 20 is the sample standard deviation divided by sample size is 30. So here I'm supposed to find 0.05. Why is it 0.05? Because I was told confidence level of 95%. Confidence level of 95% mean significance level of 5%, right? So this is the significance level of 5%. I'm given the confidence level. Okay, 0.05 divided by 2. What was the sample size? It's 30. 30 minus 1 is 29. I had to figure out this value over here. So let me stop the video, share the screen, and go to the t-distribution table. Okay, we have the t-distribution table over here. So I'm looking at, in terms of one tail, I'm looking at 0.025. Why am I looking at 0.025? Because if you remember, this is a two-tail test, and 0.05 is the full significance level. It needs to be segregated into two sections. So if I'm looking at the one tail, it should be 0.025. If I'm looking at two tails, it should be 0.05. Don't mess it up over here. So then, under that column, I had to look at degrees of freedom, which is 29. 29 is over here. So my key value is 2.045. 2.045. So I'm going to include that value in my calculation as 2.045. So 120 plus or minus 2.045 into 20 over 30. So I'm going to segregate this into two sections. Mu lower limit, L stands for lower limit, and mu upper limit. So the mu lower limit is 120 minus 2.045 into 20 over 30. Upper limit for mu is 120 plus 2.045, 30. So what is the lower limit? I'm going to calculate this. 120 minus 2.045 into 20 over 30. That gives me 112.53. Similarly, for the plus value, I just have to change the plus value over here. That will give me 127.47. 27.47. So therefore, the 95% confidence interval, I'm going to name it C dot I dot confidence interval for true mean project delivery time. That is what we were given in the question, project delivery time for the company, Innovate company, is approximately 112.5 to 127.5 days. So what does this mean? This means that the company Innovate Tech can be 95% confident, that the average delivery time for its software development projects falls within 112.5, no, 127. So that's the answer. So this, you should be able to quickly do this within about 5 to 10 minutes within that time frame, because this will be a sub part of a bigger question. So if you have any questions here, please ask me. You can unmute yourself and ask, or send a direct message and ask. Please note, there is a question on confidence interval estimation for population mean when population standard deviation is unknown. Because of that, we are using the t distribution. And if you don't have any questions, we can move to question number 4. Okay, share the screen. Question number 4. So in this case, I want you to take again about 5 to 10 minutes and try and answer question number 4. Okay, let's have this question as well, guys. So let me switch on the camera. So question number 4. So first thing is when you're reading question number 4, there is also a confidence interval estimation question specifically for population proportion. That's what they're saying. So I'm going to write down P bar as this is the first thing I'm doing is a confidence interval estimation question for population proportion. Okay, so P bar is my sample CTR proportion, click-through rate proportion, which is given by 150 over 1000, 150 over 1000, which is 0.15, and my sample size is 1000. So in this question, the formula that I'm looking for, the formula around confidence interval, around the confidence interval for proportion, population proportion is given by pi. Population proportion is symbolized by pi. Pi equals P bar plus or minus. What am I using? The Z distribution, Z alpha over 2, P bar 1 minus P bar 1 n the square root of this. Don't forget, there are two conditions here. You have to write that down. Given that NP bar is greater than 5 and n times 1 minus P bar is greater than 5. So first things first, I need to check whether NP bar is greater than 5. N is 1000, P bar is 0.15, clearly it is greater than 5. N times 1 minus P bar, that is 1000 into 0.85 equals 850, that is also greater than 5. So these two conditions are met. No issues there. So let's go ahead and do the calculations. Pi equals P bar is 0.15 plus or minus Z, and the significance level is 0.05 divided by 2 times P bar is 0.15 into 1 minus 0.15 divided by n sample size is 1000 square root of this. So like before, I have my lower limit for population proportion. Population proportion is 5, and the upper limit for population proportion. So the lower limit would be 0.15 minus Z 0.05 divided by 2 is 1.96. I hope you remember that, or else you can get it from the Z table. 2.85 divided by 1000. This would give you 0.1278. And the upper limit will be 0.15 plus 1.96 into 0.15, 0.8,000. And this would give you 0.1721. Okay, so 1.96 is the Z value I took from the table. So what we can say here is for this particular company, web crafters can be 95% confident that the actual CTR of their campaign falls within 12.79%, 17.21%. Why am I using percentages? Because this is a proportional value. Okay, so let me know if you have any questions here. Drop me a direct message, or you can unmute yourself and ask. This is a confidence interval estimation for population proportion. So we are using the Z distribution. If not, no questions are there, you can try question number 5. For this, you might need about 10 to 15 minutes. So take between 10 and 15 minutes and try the question. Use a hypothesis question for one sample test. Okay, so I will do this question, guys. I don't know whether you're done or not, but I'm going to start doing the question. So when you're looking at this particular question, you need to identify, okay, what are they asking for? They're asking for a hypothesis question, testing the hypothesis. Significance level is given at 0.05. Sample size is 25. Sample mean is 9. Sample now identify samples and the deviation is 1.5. Then you know, okay, sample standard deviation is given means I have to use the t distribution because I don't know the population standard deviation. So what is my H0 and H1? That is very important to identify. What is the customer service department saying? Due to recent software update, the average time spent on support calls has increased from its previous average of 8 minutes. So they are saying for some reason, because of this software update, average time spent on support calls has increased from its previous average of 8 minutes. That's what got told. Okay, let me stop my share, switch on the camera. How do we go about answering this question? Question number 5. So is hypothesis test for mean with one sample? That's the first thing you need to identify. It's a, let me just write it down, hypothesis test for mean with one sample. That's the question. I need to first figure out what my H0 and H1 are. My H1 is they're telling me, let me define mu as the average time spent. Mu is the average time spent. So they're telling that H1 is mu greater than 8, right? Because they're saying it has increased more than 8. So remember, H0 has that equal sign, which I always mentioned to you about. So H1 tells me mu is greater than 8, average time spent is greater than 8. Therefore, I can write down my H0 as mu is less than 8. So from this, what do I identify? I identify this is a one-tailed test. That's the first thing I need to note down. And not just a one-tailed test. It is also a upper tail test. So let me just draw that so that I don't make a mistake going forward. So there's some key critical value here that I need to figure out. And this is the rejection region, reject H0 region. Okay, so I'm just going to keep that there so that I don't forget it's a one-tailed test. Okay, so let me write down everything that I have. Alpha is 0.05, that is the significance level. Sample size was given 25. Sample mean is given 9. Sample standard deviation was given 1.5. Since I can say since the population standard, I'm using short form here, standard deviation is unknown. We can use the t distribution. I just note that down so that the reader knows that I've understood the question. So therefore, there's something called degrees of freedom. That is the sample size minus 1. Sample size is 25 minus 1 is 24. That's degrees of freedom. I have to calculate two things in this question. The first thing is I have to calculate the t-test statistic. The second thing is I have to calculate the t-critical value. Those are the two things I have to calculate. The t-test statistic is the value that I calculate given these data, right? The t-critical value is this value over here that I have to calculate. As I always say, it's the benchmark value against which you compare the t-test statistic. So let me first calculate the t-test statistic value. So what is the equation? X bar minus mu over S over root 10. So what is X bar? X bar is given to me 9. Population mean, I'm going to take it as 8. Okay. Divided by S is 1.5. Divided by sample size is 25. What do I get here? 9 minus 8 divided by 0.5 square root of 25. I get something around 3.33. 3.33. That's the test statistic. Now I calculate the T critical value. Calculate the T critical value. What is that? 0.05. Remember, I'm not dividing it by 2. Why am I not dividing it by 2? Because it is a upper tail test. So 0.05, degrees of freedom is 24. Let me go and check what that value is. My T distribution table. Go to this table. So remember, now I have a one tail test of 0.05, 4 degrees of freedom, 1.71. Okay, so I'm looking at my one tail is 0.05 and degrees of freedom 24 is 1.711. So that is what I include here. That is what I include here, 1.711. Okay. Now again, I'll just draw this, draw the graph that I drew before because I have the values with me now. It's a T distribution. And over here, I have the critical value, T critical. And I know that value now is 1.711. This is the rejection region, rejection region. Where is the T test statistic? It could be somewhere over here. T stat, because it's 3.33. So clearly, since my T stat is greater, my T stat is greater than my T critical value, I can say that we reject H naught. Remember, I always tell you can't stop here. You have to say at the significance level alpha equals 0.0. That is not it. That is only the conclusion. What is the interpretation? This means that there is sufficient evidence to support the claim, what was the claim? That the average time spent, on support pause has increased beyond 8. So that's the answer. So ideally, you should take between 10 to 15 minutes to answer this question. If you have any questions, please send me a message and ask. If not, we can move to the next question. So I'll not give a break, guys, because there are only 2 more questions left, and we can finish off early if we just go ahead and finish the questions. So only 2 more questions. We'll finish those 2 and then end the class. So if you have any questions on this one, hypothesis test for one sample, please ask. If not, we'll move to the next question. Just take a screenshot. Okay, you have questions? Next one. Question 6 and question 7, last 2 questions. So for question 6 is a long question. Take about 15 minutes to answer it. We'll try it out 15 minutes time. Take about 15 minutes and try and answer the question. Okay, let me start this question for you all. First thing is identifying what this question is about. There is a hypothesis test when there are two samples and it's hypothesis test for a mean, and assuming that these two samples are independent and also assuming population variances are equal. Significance level is given at 0.05. Right. Let's see how we do this question. Okay. Question number 6. So a lot of information provided. Alpha is 0.05. I'm gonna name brand A as NA. The sample size is 21. Brand B as NB. Sample size is 25. Sample mean is given to me as well. X bar A, we name that as X bar A, 105,000. X bar B is 95,000. Sample standard deviation of brand A, 20,000. Sample standard deviation of brand B is 18,000. Let me call mu A, population mean for brand A, as the average monthly sales for brand A. Mu B is the average monthly sales for brand B. So my H0 and H1 are quite straightforward. H0 is where these two are equal. In other words, there is no difference between the population means for brand A and B. So the difference between mu A and mu B is 0. That's H0. H1 is mu A is not equal to mu B. In other words, there is a difference between mu A and mu B. Okay. So as always, what do I do first? I have to calculate two things: the T statistic value and the T critical value. So what's easy to do first is let me calculate the T critical value. So the T critical value, and remember this is a two-tail test. T critical value is T 0.05 is the significance level divided by 2, because it's a two-tail test. By looking at your H1, you can figure that out. Degrees of freedom. Well, it's a two-sample test, so you have to add the two sample sizes, 21 plus 25, deduct 2 from it. So you're looking at T 0.05 divided by 2, comma, it is 21 plus 1, 40. Okay, so let me have a look at the T table. In this case, let me share the screen. So if I'll give you the possible the T tables, guys. The correct T tables. Okay. So in this case, I'm looking at the two-tail test. So two-tail is 0.05. That's my significance level, and the degrees of freedom I'm looking at is 44. So the second column, 44, is over here, 2.015. Okay. This is the value I'm looking at, 2.015. So let me include that value. My calculation, 2.0154 plus or minus. Right. Also, let me draw the visual. Here I have 0. On either side, I have plus 2.0154 and minus 2.0154. Those are my T critical values. And this is the these are the reject H0 region. Okay, now the hard part, which is to calculate the T test statistic. That will take a little bit of time. Let's have a look at it. So what's the equation that I need to use to calculate the T test statistic? In this case, it's this equation. It's A minus XB bar minus mu A minus mu B divided by the sample pool variance times 1 over A plus 1 over B. The sample size, the square root of this. How do I calculate SP square? SP square is equal to sample size of brand A minus 1 times sample variation of brand A plus sample size of brand B minus sample variance of brand B divided by sample size of brand A minus 1 plus sample size of brand B minus 1. So first let me calculate SP square, that is the sample pool variance. So in this case, my sample pool variance would be sample size of brand A is 21 minus 1 times sample variance of brand A is 20,000 squared, because 20,000 is my sample standard deviation. I need to square it because here what I have to include is the variance value plus sample size of brand B 25 minus 1 times sample variance of brand B is 18,000 squared by 21 minus 1 plus 25 minus 1, and that would give me a very big value, but let me just write it down here. And you can of course keep it stored in the calculator also. That makes it easier. So I get a very big value like this. Now what do I have to do? I have to include this SP squared value in my t-test statistic value over here, right? So let me calculate the t-test statistic value. T-statistic value. So that would be 105,000. That is my X bar A minus X bar B is 95,000 minus mu A minus mu B. I'm going to take as mu A minus mu B is 0. Okay. This value over here, I'm going to take it as 0 divided by SP squared is this big value over here. I'm not going to write it again. Times 1 over 25 plus 1 over 21. So this value is substituting this value. And when you calculate this, you will get 1.78. So if you look at your graph, you had plus 2.0154 on one side for critical value. On the side, you had negative 2.0154. The middle you have 0. And where is your t-test statistic? It will be somewhere over here. T-test statistic is somewhere here, which means since your t-test statistic is less than the t-critical value, we fail to reject. H0 at alpha equals 0.05. So what does this tell us? This suggests that there is no statistically significant, there is no statistically significant difference. There is no statistically significant difference in the average monthly sales between brand A and B. So that's what I did. Okay, so what did I do? Let me quickly run through it again. I just noted down all the values that I have here because it's easier for me from the table. So I had significance level, sample size, sample mean, sample standard deviation. I defined my population mean for brand A and brand B. I wrote down the H0 and H1. So H0 is simply there is no difference between the two brands. H1 is telling there is a difference. Then what do? I calculate the two values, T critical value and the T test statistic value. T critical value is simply 0.05 divided by 2. because it's a two-tail test, you have to look at degrees of freedom, is the sample sizes added -2. There are two samples. So you add the two sample sizes and you deduct 2 and you get plus or minus 2.0154. That is your T critical value. You keep it at that and you calculate your T test statistic. And for your T test statistic, you need this pooled sample variance, which is given by this equation over here. So I calculated my pooled sample variance first, included that value into the T test statistic value. I get 1.78. And in my graph, I see that 1.78 is within the not rejection region because these are my rejection regions. So I say since my T test statistic value is less than the T critical value, we fail to reject H naught at equals 0.05. This here is my conclusion. This is my conclusion. And this is my interpretation. Okay. So this is my interpretation. It's important to have an interpretation and a conclusion. Right. So if you have any questions there, please send me no questions. If not, we can move to the final question and end the class. If you have any questions, please ask. If not, let's move to the next question. Okay. Let's go to the final question, which is a one-way ANOVA question. So you don't have to go through, you don't have to do this question now in full. So let me do it because it will take a little bit of time and we can finish the lesson soon then. So just read the question, take a couple of minutes, read the question first, and then we'll do this question. Okay, I hope you read the question. So it's a one-way ANOVA question. Let's try and attempt this particular question. So let me switch on the camera. Stop sharing. Right. So we try and attempt the final question for today. Question number 7. Okay. First things first, ANOVA was used when there are more than 2 samples, and we are testing for population mean. Although ANOVA stands for analysis of variance, we are testing for population mean when there are more than 2 samples. So I need to write down my H0 and H1 first and foremost. H0 would be that all 3 means are equal, and H0 would say not all mu j are equal. Why am I saying mu j? Define what j is 1, 2, 3. That is not all mu1, mu2, mu3 are equal. Okay, so I write that down. That's the first thing I do. Next up, I need to calculate the mean values for each of these three areas. Okay, so x1 bar, x2 bar, and x3 bar. That's what I have to calculate. So for advertisement 1, channel 1, advertisement channel 1, advertisement channel 2, and advertisement channel 3, what are the average values that I get? So for that, what I do is for advertisement channel 1, it's 254 plus 263 plus 241 plus 237 plus 251 divided by 5. So we get 4 plus 263 plus 241 plus 237 plus 251. There are 5. So I would get 249.2. 249.2. That's for the first one. For the second one, I'm not going to write down all the data points. 200 plus up to 204 divided by 5. So that is, I have 200 is my first data point, 192, 197, 206, 204 divided by 5. I get 205.8. 205.8. The third one is the first data point 249.2. Last data point is 205.8. So there are only 3 data points. Let me call them one. So that would give me 249. Sorry. X3 bar is so this is X3 bar. I made a small mistake here. This is X3 bar. X2 bar I have not calculated. 234 plus 216 by 5. So these are the mistakes that can happen when you're doing the calculation. And it obviously takes time then. 234 plus 218 plus 235 plus 227 plus 216 divided by 5 to get 226. And then my x double bar, which is simply x1 bar plus x2 bar plus x3 bar divided by 3. That's the full mean of all this. So 249.2 plus 226 plus 205.8 divided by 3. So I get 249.2 plus 206 plus 205.8 divided by 3 gives me 227. Okay, so I have these numbers calculated. Fine. Now the tough part. The sum of squares among and sum of squares within. So sum of squares among is a little bit easier to calculate. So there is simply your x1 bar minus x double bar square plus into the sample size of the first one plus x2 bar minus x double bar square into your sample size in the second one plus x3 bar minus x double bar square into your sample size. So x1 bar we calculated 249.2. Okay, so 249.2 minus x double bar is 227. Square that, you have 5 values plus x2 bar was 226 minus x double bar 227 squared 5 values. X3 bar is 205.8 minus 227 squared into your 5 values. So what do you get here? These are your sum of squares among. So what do you get here? 49.2 minus 227 squared plus 6 minus 227 squared plus 205.8 minus 227 squared. Get this value into 5. I will get 4716.4. That is my sum of squares among. So when I calculate my sum of squares among, I need to calculate my mean squares among. So what is mean squares among? Sum of squares among divided by the degrees of freedom, number of groups minus 1. C is number of groups minus 1, right? So sum of squares among was 4716.4 divided by number of groups, you have 3 minus 1, you will get 2358.2. So we calculated that and keep it aside. Now we go to the long calculation, sum of squares within. So in this particular calculation, sum of squares within, it's what you need to do is you take the first data point from your first group, deduct the group average square plus is of 1, 1. Then you take x1 2 minus x1 bar square plus likewise you have 5 data points, x1 5 minus x1 bar square plus next you go to the second group, x2 1 minus x2 bar square plus x2 2 minus x2 bar square plus likewise you have 5 data points. So from the second group, 5th data point minus x2 bar square plus you go to the third group, which is from the third group, first data point minus the group average plus second data point from the third group average square plus likewise 5th data point minus group average square. So that would be 254 is the first data point, 249.2 is the group average for the first group. You have 5 data points, so the last one is 251. The last data point of your first group is 251 minus 249.2 square plus first data point from a second group is 234 minus 226 square plus last data point of your second group is 216 minus 226 square plus first data point of your third group is 200 minus 205.8 square up to 204 minus 205.8 square. Now, how do you do this in the calculator? Well, there is a method. You go to, well, in this particular calculator at least, you go to menu and you select statistics, 6, go to the first variable, click on 1, and now I enter the data points. What are the data points I enter here? The values that are given for the first group. So what are the values for the first group? 254. I enter it by clicking on equal. Second data point is 263 equal. 241 equal. 237 equal. 251 equal. Now I'm going to click on AC and what I have here called option. Click on that, go down, click on 2, which is variable. And from this, what I'm going to calculate is this one, the population variance. Okay, so population variance is 2. And this is what I want. I click on equal, I get 86.56. Now, what I'm trying to calculate is this particular value over here. I'm trying to calculate this value first. Then I'm going to calculate this value. After that, I'm going to calculate this. So this 86.56 is only sigma squared x. Now remember, sigma squared is usually whatever value minus average squared summation divided by the sample size. Okay, so I need to cross multiply by the sample size to get this value. Why do I want to get this value? Because this is the value I have over here. These are the sum of squares, right? So what I have here are the sum of squares. So sum of squares is basically my population variance into sample size. So what I do here is I get this value, I multiply it by 5, and then I store this value. How do I store this value? At least in this calculator, there's something called STO, and I click on STO, and then I have to store it to some value. So there is, I don't know if you can see here, but here I have A. So I'm going to store it to A. So can you see? Now it's stored. Then again, I go back to menu, statistics, one variable. Now I'm going to include the second data points. So that is from the second group, 234, 218, 235, 227, 216. In C option, go down, variable, samples and sample variation equals into 5 equals store it to B. That's also done. Then the final group, statistics, variable, final group is 200 equal 222 equal 197 equal 206 equals to option down variable population standard deviation equals times 5 equals store it to C. That's done. Now I'm going to calculate A plus B plus C. So it's simply alpha A plus alpha B plus alpha C. Because I've already stored my values in ABC and I will get 1119.6. And that is the value I need. So if you can do this fast, you can get these values, the sum of squares within, quite fast. Okay, so since this is recorded, you can go over it again and see how I did it. So after I calculate my sum of squares within, I calculate my mean squares within, which is simply sum of squares within divided by sample size. There are 15 data points in total minus the number of groups. So sum of squares within is 1119.6 divided by 15 minus 3. There, 1119.6 divided by 15 minus 3. I get 93 points. Okay, so I calculated the mean squares within. After that, what do I do? Well, in ANOVA, I use the F statistic. All of this was done to calculate the F test statistic. F test statistic is mean squares among divided by mean squares within. What was my mean squares among value? 2358.2. 2358. 2 divided by mean squares within 93.3. Right here, 2358.2 divided by 3.3, and I get 25.275. Okay, now that is my F statistic value. Now I need my F critical value. F critical value, which is simply significance level at 0.05. I have 2 degrees of freedom here, 2 types of degrees of freedom. 1 degree of freedom associates with the mean squares among. The second degrees of freedom associated with the mean squares within. Mean squares among degrees of freedom is C minus 1. So C minus 1 is 3 minus 1, comma. The mean squares within degrees of freedom is N minus C. That is 15 minus 3. So F 0.05, 2, comma 12. Now I need to go to my F table. Let me switch off the camera here. Share screen to my F table values. It is given here. So F table alpha 0.05, right? And the first degree of freedom is 2. That's what I look at. That is associated with the mean squares among. The second degree of freedom is associated with the mean squares within. So I have 2 degrees of freedom and I have to look at 12. So I get 3.8853. 3.8853. Stop sharing. And I include that value here. 3.8853. And remember, what does my F graph look like? It's from 0 onwards, something like this, right? So my critical value is 3.8853. This is the rejection region. Reject H0. Where is my F stat value? Well, it's somewhere over here, stat value. So I can say since my F stat value is greater than my F critical value, I can say we reject H naught at alpha equals 0.05. What was H naught? At the beginning, I defined H naught that all population means are equal. But in this case, I'm rejecting, which means there's some population means that are not equal, which means this is going to be a longer sum, which means I have to use the Tukey-Kramer method procedure to understand which of the population means are not equal. Okay. So let me go into that. So now what am I doing? I'm using the Tukey-Kramer procedure to understand which of the sample means are not equal. So how do I do that? First, I calculate the absolute mean differences. Absolute mean differences, that is x1 bar minus x2 bar, x1 bar minus x3 bar, and x2 bar minus x3. What are the values here that I get? 249.2 minus 226. Here you will get 23.2. The next one is 249.2 minus 205.8. Here you will get 43.4. And x2 bar minus x3 bar, 226 minus 205.8. Here you will get 20.2. Right. So those are the absolute mean difference values that I've calculated. Next, there is something called the Q value and the critical range associated with the Q value that I need to compute. Right. So in that case, its Q value is associated with 0.05 significance level. The first degree of freedom is the groups, number of groups, C, which is equal to 3. The second degree of freedom is N minus C. Sample size is 15 minus number of groups is 3. Well, how do I figure out this value? Again, I go to my Q table. Tukey test critical values table. I look at alpha equals 0.05. The first degree of freedom I'm looking at is 3, and under that 12. So I have 3.77. So I include that value, 3.77. Include that value over here, 3.77 over here. And then I calculate the critical range, which is this Q alpha value, which I calculated over here. Okay, this is Q alpha times mean squares within over divided by 2 times 1 over nj plus 1 over nj prime. That's the equation. So Q alpha is 3.77. Mean squares within I calculated 93.3 divided by 2. Sample sizes are the same, thankfully. So it's 1 over 5 plus 1 over 5. If you calculate this, you will get 16.285. And then finally, what do I do? Final step is, since x1 bar minus x2 bar, you compare this value with the critical range, and you see that x1 bar minus x2 bar is greater than the critical range. Also, you see that x1 bar minus x3 bar is greater than the critical range. And finally, x2 bar minus x3 bar is also greater than the critical range. So what does this tell us? This tells us that there is a significant difference between, there's a significance difference between each pair of means at the 5% level of significance. And finally, you can say, we can conclude, but the mean number of ticks generated by your first channel, that advertising channel, is greater than the second and third. That's what you're saying here. we can conclude that the mean number of clicks generated by your first ad channel is greater than the second one, first ad channel is greater than the third one, and finally, your second ad channel is greater than the third one. That's what you can say. And with that, you can write that comment and finish the question. So that is the longest question that you will get. It will take about 20 to 25 to 30 minutes even. But if you can practice it much more and you can practice more questions, I'm pretty sure you can get this done within about 20 minutes. That's it. If you have any questions, you can ask me now. If not, we can end the lesson. If you have any questions, please ask. If there are no questions, I can finish the lesson. Okay, seems like there are no questions, guys. All the very best then. I wish you all the very best. Do a lot of questions because it's very important to do that. To be highlighting that from the very beginning. Do all the example questions, and then at the exam, you won't have any problem. You do all the example questions, and you're very thorough with those questions. Thank you very much. Then I will stop the recording, and I will share this recording on Moodle.